This is section 5.5, graphs of sine and cosine functions. Here we're going to graph y equals the sine of x and y equals the cosine of x. So we're going to begin with the sine function, and as we talked about, it is periodic with 2 pi, and the cosine is also periodic with 2 pi, okay? So what do you notice the difference between the sine and the cosine? As you can see here, the cosine has the point 0, 1 on the graph, and the sine has the point 0, 0 on the graph. And we can see those, right here. And we can obtain those from the unit circle as well. We can also see that the sine of pi is equal to 0, and you might think about the unit circle and being at pi, and the sine is the y value. So this would be the sine of x, and that would be 0. Okay, and x would be pi. So we can also see that here with the cosine graph. If we are at pi, you can see this is negative 1, 0 again, and here the cosine is negative 1. So the cosine of pi is negative 1, and I guess I should have put the sine of pi here is 0, okay? So that is why this point, negative 1, that's why this point, pi, negative 1, is right here. When x is pi, right here. The cosine of pi is negative 1. And you can sort of see the pattern, and it repeats itself infinitely, goes on and on and on. It doesn't just stop here. So it's quite interesting to look at those, and now you can see them together. And as you can see, the sine goes through the origin, and you can see that the sine of 0 is 0, and the cosine of 0 is 1. Okay, that would be this point here if we would have 0 here. 1, 0. The cosine is 1, and the sine is 0. And you can do the same for any of these values at pi or at negative pi. Okay, let's talk about the characteristics of these graphs. The domain is all reals, and the range is negative 1 to 1. So that's really important because we have 1 and we have negative 1. And that's the range of the y values. Okay? And the sine of x is symmetric with respect to the origin. The sine of x is an odd function, and the cosine of x is an even function. And these two functions differ by a horizontal shift of pi over 2. And you can clearly see that if you moved this graph over pi over 2, you would have this exact graph of the sine of x if you move the cosine pi over 2. Okay, let's go ahead and take a look at what happens when we have a constant in front of multiplied by each one of these functions. So to graph these, we're going to be looking at relative minima, relative maxima, and the x-intercepts. So the graphs of both the sine and the cosine alternate between their min and their max. And there is an x-intercept for each quarter of a period, okay? So if this constant that you are multiplying by the outside of that function, if the absolute value is greater than 1, we have a vertical stretch. If it is a fraction, a number between 0 and 1, we have a vertical shrink. And if that constant is negative, we will have a reflection across the x-axis, okay? Let's talk about the amplitudes. The amplitude represents the amount of deviation from the central position of the sine wave. And the amplitude is half of the distance between the max and the min. So that amplitude is halfway between, if this is my max and this is my min, that amplitude is this distance. Okay? Should have moved this here. Okay? So that amplitude is half of that distance between the max and the min of the function. Let's go ahead and identify the amplitude of each one of these functions. First of all, as you can see, the amplitude here will be the absolute value of that constant, which is equal to 8. The amplitude in number 2 for g of x is equal to the absolute value of 2/3, and that's just equal to 2/3. Now let's try to graph the function 2/3 times the cosine of x. Well, keep in mind that that amplitude is the absolute value of 2/3, which is equal to 2/3. So we will go 2/3 this way, half of the distance between the max and the min, and 2/3 this way, okay? We will also place our x-intercepts. If you can remember what they said about our x-intercepts are a quarter of each period, okay? So if we divide a period of 2 pi, you can see what we have here. So we will cross pi over 2, 3 pi over 2, and now we'll go ahead and graph the original function in a gray. How about that? And as you remember, we have the cosine function begins here, comes down here, comes around here, kind of goes up like that. The only problem is this is supposed to be more rounded. There we go. Okay, so now with just an amplitude of 2/3, we'll still have our x-intercepts there, but we will have our max and min values decreased. And now you can see we will go right into that x-intercept, come around, and go around. Okay, let's try number 4. So we have an amplitude of the absolute value of -2, which is 2, but we now also have this negative. So we will have a reflection across the x-axis. Okay, so let's go ahead and sketch our original sine of x function, and keep in mind that that sine of x starts at this origin, goes there, and then we have our relative max and a relative min, and then we just kind of come around like this and come around like this, okay? And maybe I should have written that this is the cosine of x and this is the sine of x, okay? And now what happened? Now our amplitude is 2. So now we will have the distance here to be 2 and the distance here to be 2. Okay, and we have the reflection. So we will actually at pi over 2 have a relative min of 2 and a max here of 2, okay? There we go. And this is the graph of the opposite of 2 times the sine of x. Y equals that. Okay? So now let's talk about when we introduce another constant which will have horizontal shrink and stretching with the graphs. And the factor b here is going to affect the period of the graph, okay? So y equal to sine of x has a period of 2 pi, but when you have y equals the sine of 2x, the period is just pi, okay? So that is written right here. We would actually be dividing by that constant. And so in this case, we would take 2 pi and divide it by 2. 2 pi divided by b, and that would just give us a period of pi. Okay, and that is the same for the sine of x as well. And here, if we would have 1/2 x, so here we would have b equal to 1/2, we would actually then, and this period of the sine of x, I guess it wasn't typed here. Of course, we know that's 2 pi. And so now we'll take 2 pi and divide it by b. 2 pi divided by 1/2, and that's 4 pi. So now the period is 4 pi. Okay? You can see that right here. And then here is the period pi. Okay, so now to analyze the period of a sine or a cosine function with a negative coefficient on x, and that's when b is greater than 0, we are going to do some rewriting. So as you know, we have that the sine of the opposite of b times x, we know that that's an odd function. So this negative now can go on the outside. And the cosine of x is an even function, and so that is the same. So we'll keep in mind that this is a property of an odd function, and this is a property of an even function. So we'll be using these properties to graph these. Okay, let's begin with y equals 2 times the cosine of negative 4x. And remember, since the cosine is an even function, that's equal to 2 times the cosine of 4x. Let's start with our amplitude, okay, and that's the absolute value of 2, and that's equal to 2. Our period, we're going to take 2 pi, and we're going to divide it by b. And in this case, let me write that down, b is equal to 4. And in this case, a is equal to 2, of course. Okay, so now we have 2 pi divided by 4, and we have a period of pi over 2. So what does this mean? We have one complete cycle. Whoops. Between 0 and pi over 2, an entire cycle. And so now we must have that 4x is going to be between 0 and 2 pi, and you can see that x will be between 0 and pi over 2. Okay, so what we're going to do is we're going to divide pi over 2 into fourths. So how are we going to do that? 1/4 of pi over 2 is equal to pi over 8. Okay? So if we start at 0, 2, remember our amplitude is 2. So we're going to be starting here at 2. I'm going to write over that right here at 2. And now And so our first step is going to be 0 plus pi over 8, and that's equal to pi over 8. So we'll have pi over 8, 0. Okay? That's where we'll begin. And then in the second case, we'll have 0 plus 2 times pi over 8, and that will give us 0 plus pi over 4, or pi over 4. And then that gives us pi over 4 negative 2. Okay? And then the third step, we'll have 0 plus 3 times pi over 8, and that will give us 3 pi over 8, and we'll have 3 pi over 8, 0. And then our last step would be 0 plus 4 times pi over 8. So we've walked 4 pi over 8s. That gives us pi over 2, and we'll be at pi over 2, 2, because of that amplitude of 2. So we can go up here and graph, and we have pi over 8, 0, pi over 4, negative 2, and then pi over 2, 2. I forgot that one, 3 pi over 8, 0. Okay, and these just come around like this. They're supposed to be very smooth, and there you have it. Okay, now let's talk about if we add and subtract from a constant from that angle. Okay, so what we're talking about now is this C and this outside function, okay? Outside constant. So if we have the graph and we have minus h, whoops, I want to do that in yellow, included here, that is a horizontal shift of the absolute value of h units. Of course, if h is positive, the shift is to the right. H is negative, the shift is to the left. Now, if we have these graphs and we have bx minus c and bx minus c for both the sine and the cosine, both of these will have a change in period and a horizontal shift. And this horizontal shift to the left or the right is actually called a phase shift, and we'll have an example with that. So for a positive value of b, we can use this inequality right here to solve for this phase shift. Okay, let's go ahead and look at number 6. We're going to graph the function over one full period. We'll identify the amplitude, the period, and the phase shift. Okay, so let's start with the amplitude, something we've done several times. And so that amplitude is the absolute value of 3, and that's equal to 3. And that is why we have this value here. We'll have this as 3. That's our amplitude. Okay, let's talk about the period. So that period, remember, we're going to have 2 pi, and we're going to divide it by b, which is 2, and we will have pi as our period. Okay, then next we will talk about one cycle, and let me go ahead and highlight this. And then of course that was A. Okay, so we have one cycle is 2x minus pi over 4, and that's going to happen between 0 and 2 pi. Okay, so now I'm going to add pi over 4 to all parts of this 3-part inequality, and that is 2 pi plus pi over 4. And then we have pi over 4, and then that's 8 pi over 4 plus pi over 4 is 9 pi over 4. Okay, now we're going to divide all parts by a positive 2. And we have a starting point at pi over 8, and we have an end point at 9 pi over 8. Now we're going to take a fourth of pi, okay? So our fourths, so we're going to have 1/4 of pi, and that's equal to pi over 4. So where we're going to start is pi over 8, 0. Okay? And this should have been pi over 8. Sorry. Okay, so now, excuse me, our fourths are pi over 4, and with that we are going to start at pi over 8, 0. So let's begin with our first step. We're going to have pi over 8, and we're going to start adding a fourth to each one of these places. So this is going to be 3 pi over 8. And this keeps us, or gives us, our first point, 3 pi over 8, 3. And keep in mind that amplitude is 3, okay? So that's 3 pi over 8, 3. Okay, let's go to our second point. Where we were before, we're going to start at pi over 8, but now we're going to add 2 pi over 4s, and that gives us 5 pi over 8, and now we have 5 pi over 8, 0. Okay, let's go to our third, and now remember, we're going to be at pi over 8, and now we're going to add 3 pi over 4s, and that gives us 7 pi over 8. So that gives us a point, 7 pi over 8, negative 3. And finally, 7 pi over 8 and negative 3. Okay, and then finally, we'll be at pi over 8, and we're going to add 4 pi over 4s, which is just adding pi. And that gives us 9 pi over 8, and now we have 9 pi over 8, 0. Okay, so now we can sketch this graph. And it actually comes down like this. And then we come around like that. Okay. And you can see the graph here. I think this was nice to have. Y equals 3 times the sine of 2x without that minus pi over 4. Okay, to find the vertical shift, we have to remember that when D is positive, the graph will shift up, and when D is negative, the graph will shift down. Okay, so these are vertical shifts. Okay, so let's go ahead, and this will shift the graph, or take all points. Will be shifted up 2 units on that sine graph. Now, as you can see, this is the same graph as we have before, but all we have done now is added this vertical shift. So every one of our points that we had before, we will shift up. I'll just write one of these examples. So our starting point is pi over 8, and then now we're going to have 0, 2, and that's going to be pi over 8, 2. Okay, and then that first point, we're going to have 3 pi over 8, and then we'll have 3 plus 2, and that's 3 pi over 8, 5. And so forth. And you can just go ahead and finish that and check that out, and you'll see that this graph looks like that. Okay, let's now just talk about the properties of the general sine and cosine functions. Okay, let's just take this in general, and we are given a very nice sine and cosine with all of the transformations. We are summarizing what the amplitude is, absolute value of A. Period is 2 pi divided by that B. The phase shift is that C divided by B. And our vertical shift is D. One full cycle is given when we place that Bx minus C within that three-part inequality. Our domain is all reals, and that range has that amplitude plus and the amplitude to the left, also with the plus D. So we have the opposite of A on the other side. So modeling this sinusoidal behavior, we're given this example about a monthly high temperature for Buffalo, New York, and it peaks at an average high of 80 degrees in July. And you can see that right here. So this must be July. And down to an average high of 32 degrees in January. And assume that this pattern for monthly high temperatures continues indefinitely and it behaves like a cosine wave, okay? So we're going to write the function in the form h of t equals a cosine bt minus c plus d, and we're going to be modeling these average high temperatures. And h of t is the average high temperature for month t. Now notice when we said July was 6, that's because January is t equal to 0. So this is actually January, February, March, April, May. June is the fifth, number 5, representing x equal to 5, July, and so forth, okay? So I thought that was important to point out. Let's talk about the amplitude here. Just looking at that graph, what do you notice? Our amplitude is always half of the distance between our high and low. So we have high minus low divided by 2. And as you can see, 80 is the high and 32 is the low. And they actually gave that to us. And that's equal to 24. So at this point, let's go ahead and just write what do we have so far. So far, we've got the cosine of bt minus c plus d. And guess what we have already? We now have our 24, okay? And that should be a negative 24, okay? Since the cosine begins here and comes around, this is a reflection. This has a negative value. So this is reflecting across the x-axis. You can see that the wave that would make that negative, okay? Let's continue to see what we have. Now we'll go to our vertical shift. D is equal to the vertical shift. And that's equal to the high plus the low divided by 2. And we have 80 plus 32 divided by 2. And we have 56. So now, what do we have here? We will duplicate that and bring that down. And now we can erase this plus D. And we can, I guess that's an awful big eraser. And now we will have plus 56. So we're getting there. Let's work on the period, okay? So the period is equal to 2 pi divided by b. Now, as you can see, our period is 12 from here. So it would be 12 is equal to 2 pi divided by b. We can cross multiply. 12b equals 2 pi, or b equals 2 pi divided by 12, which is equal to pi over 6. So now we have and instead of that b here, we will now have pi over 6 times t. So what about a phase shift? As you can see, there is no phase shift. So that means that c is equal to 0. So now what do we have? We can write that h of t is equal to negative 24 times the cosine of pi over 6 times t plus 56. And that concludes this section.